Hello, everybody. Thank you for joining us. My name is Brian Rinaldi. I lead developer relations here at LocalStack. I'm coming to you from Boston. I'm sorry in advance. I apologize in advance if there's any kind of background noise or I am not in my office or anything. I have construction going on. I just moved. It's chaos, but it's all right. I will figure it out. We will get through this. I appreciate you joining us today. We're really excited because today is our first time talking about our new product Snowflake, and we just launched 1.0 uh just last week it was. So yeah, so we have a whole big lineup of speakers today, all talking about our new Snowflake product and how to use it, and I hope you're excited because I think it's really going to be cool. Okay, so just to kind of give you a sense of what we're going to be doing, we have the intro and welcome, which is what you're in right now. Then we're going to be talking about the road to LocalStack, which is our founders, Gerta and Valdemar, will be talking about how we ended up building this LocalStack for Snowflake emulator and what to expect from it, as well as we're going to tell you what new features are in the 1.0 that we just launched. Some of you may have experimented with the preview release, but now that it's officially 1.0, we added a ton of new stuff. And speaking of that new stuff, we are going to go ahead and do some tech demos from the team that built the emulator. So we're going to get some demos of Polaris catalog, Snowflake native apps, Snowpipe, and stages. And then we're going to show you some of the resources and community things that you can use to help you get started and get your questions answered. We also will be answering your questions live here. So you can either go to Slido, which we'll get to the Slido link, or you can actually just put them in the chat. We're happy to answer your questions if they come in via your YouTube chat or LinkedIn chat. That's fine too. So okay, so who's going to be speaking? We've got, as I mentioned, Gerta and Valdemar, our founder, and yeah, here we're bringing everybody on screen. Our founders are going to be speaking first, as well as Erudit and Shemek will be doing some of our tech demos of some of the features that they built. So welcome everybody. Let's go do a round of introductions. We'll start with Gerta.
Yeah, it's lovely to be here. Thank you so much for hosting this. We're very excited about this meetup. It's been a product that's been long in the baking for us, and it's a very exciting time for us to release it now.
All right, Valdemar.
Super excited to be here. Yeah, my name is Valdemar, CTO at LocalStack here. Very excited to present the product today. We've been working quite actively on this for the last year or so. We're going to share some of the roadmap and story, how this all came to be. But it kind of really demonstrates, and it's kind of a milestone in us becoming multi-cloud as a product. With LocalStack, we started in the AWS space, and now with Snowflake, we have a second major product that we're putting out. So very excited to be here today.
Over to. All right, we'll pass it to Shemek.
Yeah, my name is Przemek. Work as a software engineer at LocalStack, based in Warsaw, Poland. Thanks for having me, and can't wait to share some exciting updates.
Awesome. And Erudit?
Yeah, and I'm Erudit. I'm a software engineer here at LocalStack. Been working for almost a year on this Snowflake emulator, and yeah, thanks for having me.
And for anybody who's been watching any of these streams at any point, you probably already know Harsh, but go ahead, Harsh.
Sure, they all know me. That's the best part about being at these meetups. But for anyone uninitiated, I'm Harsh. I work with Brian here, part of the developer relations team. And it is just so exciting to meet all of you and provide you a bunch of resources and stuff that we have been building to help you get started with your Snowflake development journey.
Awesome. Well, we're really looking forward to hearing from all of you. But let's go back to this. So that you can ask your questions, we will be using Slido. You go ahead to slido.com, you enter that code there, or you can use the QR code right there, scan it, and ask questions. As I mentioned before, you're also free to ask questions via the comments as well. We will do our best to answer your questions however you choose to ask them. And we invite you really to just participate. Part of the fun of joining these things live is you can get direct answers from us. So the whole team is here who built the product. So go ahead and ask your questions live. Okay. So with that, I'm actually going to just turn it over to Waldemar and Goethe to tell us about the road to LocalStack for Snowflake.
Wonderful. Thanks so much for the intro, Brian. And it's a pleasure to give you a bit of an overview and intro into the roadmap and how this all came to be. So first of all, so what is Snowflake, right? So the audience here may be familiar with the platform, but basically it's a cloud data platform that allows you to perform scalable data processing, right? So you can do things like uploading data files in various formats, CSVs, JSON, Parquet, and so on, uploading them to stages, what's called stages, internally more like represented as something like S3 buckets or something where you can store your data. And then you can actually run SQL statements over these files to create databases, tables, views, and so on, and run selects directly from these files, for example. There's also much more in the platform. You can run things like scheduled jobs to create ETL pipelines. So it's a very, very comprehensive data platform, effectively. It can be accessed from different native integrations and SDKs, right? So there's a Python has, for example, Pandas data frames API, Snowpark libraries, JDBC drivers, and so on. So it's very accessible from various kinds of tools in the ecosystem. And with us, with LocalStack coming more from the AWS ecosystem, it has some similarities to some of the data or big data services in AWS, services like Athena, Redshift, EMR, Airflow, etc. But it's kind of this one single managed platform that takes care of essentially all your data needs, and is one of the rising stars and one of the key players in the data space. So now, with LocalStack, we of course our mission is to enable this local development experience for developers, giving them access to a resource that they can run on the local machine. And we've demonstrated with AWS that this is very much feasible and also leads to much better outcomes in terms of developer experience, feedback loops, and so on. And we've seen a similar opportunity with Snowflake, where a couple of folks in the community were asking, has anyone come up with a local version of Snowflake that allows us to test locally, right? So we've come across a couple of forum posts, Stack Overflow posts, Reddit posts, and so on. And it's something that the community has been asking for quite some time, but to this point, it's not something that has been available. There's a few small open source projects that map a subset of the Snowflake capabilities, but not the comprehensive platform with all its query capabilities and everything. So we basically set out to go on this journey, and I'll talk a bit more how this all came to be. But generally speaking, we're solving a very similar challenge as for the AWS cloud, right? So speeding up development cycles, so not having to push sort of every change up to the data platform for running the tests, but you can actually really keep things local on your machine, running this in a Docker container and have like these really quick feedback cycles. The other aspect is avoiding resource conflicts, right? So if you have like sort of your own isolated sandbox environment, there's no risk of overriding each other's changes in a database, and things are also just becoming much more reproducible from a testing perspective. So that's just from some background why this notion of testing data pipelines locally is even relevant. And just from a kind of historical point of view, how we came to this day is the history spans a bit more than a year back, actually, and this is kind of showing interestingly also like the roadmap of a product development at LocalStack, and it very much sort of initiated and started with a POC at an internal hackathon. So we're running these hackathons at LocalStack where the team is working on innovative new ideas, and this is a lot of really cool things are coming out of these hackathons, and this is really sort of where the first starting point for this was built as a POC extension. And we then gradually over the next couple of months built a basic support for DDL, DML, and DQL. So basically being able to create tables, insert data, query data, and so on. And then sort of gradually added more and more features around copying files from stages, support for UDFs, pipes and tasks, table streams, a lot of other things that Jemek is also going to go into more detail. And over the last about 9 months or so, we've also been running a preview program. Goethe will share a couple more insights on that, where we've basically been working very actively with preview customers, early adopters who were kind of using the product. We know that it did have some rough edges until now, and we really appreciate everybody's input to make this really a polished experience that we're now able to put out as a 1.0 release. So quite exciting journey so far. And now we also have a team behind LocalStack. So of course, behind the Snowflake emulator. So of course, part of this longer term on-ramp of the product is of course building a team that can support this over time. And at this point, I want to give a huge shout out also to the team that's working on this, particularly of course the entire LocalStack team, but specifically also Snowflake. You will see Erudit today and Przemek, but also Gentris and Sabir, who've been working very actively on this. So big kudos for a huge lift and push for getting this out today. Okay. There's an exciting roadmap ahead. We'll also get more into that towards the end of the presentation. But now that we've sort of put out a pretty solid base product, there's various directions we're going to be taking this, right? So Cortex AI, for example, is a very exciting area where Snowflake is investing a lot in AI, and giving you a local testing of AI applications is something that's up and coming. State management and CI integration, we'll talk about a bit more about this, test data management, and also deeper integration between the multiple products that we're now creating, right, with AWS and Snowflake, and leveraging the synergies and integrations between those two platforms. So a lot of exciting up and coming features in LocalStack more broadly. So this is actually a screenshot I copied from our website. So you'll also find this on our website. So basically, in a nutshell, what the emulator allows us to do, very similar to the AWS Snowflake emulator, is running your tests for Snowflake data applications on the local machine, right? Local testing with these quick feedback cycles and no cloud dependency. And then it's also very easy to translate the whole setup into CI pipeline, right? Running your tests there. If you have things like automated tests that run some data transformations and then running some assertions at the end. So it's very a repeatable process, and you have these test isolated sandboxes for your testing. And then sort of once you're happy with the changes, confident in shipping changes to production without the risk of breaking things in the environment. And what's at the top of this image here is basically different applications that connect to the emulator. So we try to make it very like a turnkey integration with any existing tools like dbt, Flyway, and any other data engineering tool that's in the space to run your ETL scripts and data applications. Again, we'll see this in the demo, but just to give you like a bit of a preview here. So this is a screenshot from a dbeaver visualization. So you can see a bunch of queries on the right-hand side, and then we'll run this whole thing later against the emulator, right? So everything looks and feels the same as if you were running it against a real platform, but it's simply just running them on the local machine. You get these local feedback cycles. And as mentioned, it natively integrates with all your tooling that you might be using already, something like JDBC driver, any database visualization tools. So all these things kind of work out of the box since we're emulating on the API level, the Snowflake emulator. I'm probably not going to go into too much detail here. Again, this is just an excerpt of the features that are supported. It's quite broad at this point. So we, all the basic functionality like warehouses, databases, schemas, and tables, but then also things like Snowpipe streaming, JavaScript UDFs, and Python UDFs, tasks, table streams. So it's actually a growing set of features that you can run literally on the local machine, and a couple of exciting demos are coming up also with, for example, the Iceberg integration and Polaris catalog. So more on that also when Przemek shares the detailed updates on the features available. I just want to give a short sort of heads up on CloudPods. It's something that's not fully available for Snowflake yet, but we are actively working on making this also available with the Snowflake emulator. So as some of you in the audience may know, CloudPods is basically a mechanism for persisting the state of your LocalStack container, easily pushing it to a storage backend, and then sharing it with team members and recreating the state easily on a different machine. So again, something that we're sort of up and coming and we're working on, but it's not fully available yet. But we're looking forward to having this full integrated persistence integration with the Snowflake emulator as well pretty soon. All right, so just one or two words on how we're building this, because some of the audience might be interested. Okay, how is it even possible, feasible to build the sort of the Snowflake cloud on your local machine? I mean, as usual, as similar to what we're doing with the AWS emulator, we're just simplifying assumptions. So we don't need to provide the same level of scalability as the real cloud, of course. Security is also, of course, a different type of concern locally. And at its core, we're using a database engine, and in our case, we use Postgres. And we have a bunch of logic that sits on top of it with query processors that are kind of taking an incoming query, transpiles it, and then runs it on the PostgreSDB engine. We actually put out a blog post there earlier in 2024, so that's already slightly dated. So we'll probably put out an updated blog post pretty soon. But at its core, the system is or the blog post is still valid. So it's still conceptually the same system. We've had a lot of internal work on a new type system and other things that are much more sophisticated than what you saw in the blog post. But it's effectively the challenge of transpiling from one SQL dialect, which is Snowflake, to Postgres, and kind of making that possible. And the whole thing is written in Python, and it's running in a Docker container on your local machine. Just one quick shout out here when it comes to the implementation. So we're, among many other tools, we're using one tool that's called SQL Glot, which deserves maybe a special shout out here. It's an open source project that we're using extensively also in the emulator. It's basically a SQL query parser and transpiler, and it really allows us to modify the incoming Snowflake SQL queries and transpile them to the Postgres equivalent, which we can then execute in the targets. And yeah, we're also able to contribute a few PRs in the upstream repo. Just wanted to give a shout out here because it's a really fantastic project and it's made free and open source. And big kudos to the Tobico team for making this available. And again, as I briefly mentioned, the main challenge of what we're building here is kind of to introduce the same type system that Snowflake also uses internally, and we've spent a lot of time and effort to build our own internal representation of that type system, and we'll likely have another blog post coming out soon to describe some of the technical details of how we achieve this. Okay, I'll hand it over to Gerda for just a quick note on the customer side and how the preview program has been going.
Thank you so much, Voldemar, for this introduction. I think it's very helpful to see for everybody what we've been building and how really the Snowflake emulator fits perfectly into our story that we've been telling as LocalStack and shaping as LocalStack with our users and customers out there over the last few years in the AWS space. So I just want to take 1 or 2 minutes to give a big shout out, first of all, to everybody that's been supporting us in this journey. I have the pleasure at LocalStack to be working with our large enterprise customers as well as smaller customers from the get-go. And it's always been really eye-opening to see for people how you can really get local development done in the AWS space, and now also opening this up for the data space as a first step with Snowflake is really a big major milestone for a lot of our customers. We've had customers ask for a Snowflake emulator. We've had customers also ask for other types of emulators in the past. The reason why we focused on Snowflake is really because it allows us and our customers to build up on synergies. So the idea is that we now can work together with people that are having data teams as well as development teams that are building AWS cloud applications, and all really use and leverage the same platform, which is LocalStack, to enable these multi-cloud development environments that we're supporting here. And one big thing that I really want to highlight here as well is, me personally, I've always had the pleasure to go to all these AWS events and learn a lot from our customers, always see in their eyes the excitement about local development even being possible. It's something that is not clear to everybody who touches the space for the first time. And we're actually will be at the Snowflake Summit as well next week in San Francisco. So if you are in San Francisco at the Snowflake Summit, please make sure to come and visit us at our booth. We would love to have direct in-person conversations with all of you. In general, also, please feel free to reach out and share your use cases with us. We have had the pleasure to be working with some of our beta customers, and a huge shout out to all of them over the last year in a closed beta program for Snowflake. And we've been able to collect a lot of valuable feedback. Without them, it wouldn't have been able to build this product. being as stable as it is now with V1 and delivering value to the broader community. So a big thank you to our beta customers that have been supporting us. And if you have your own Snowflake use cases, please make sure to reach out to us. We would love to learn all the details about how you're building your data applications and how you're envisioning certain workloads to really be working also locally. And with that, I also want to give it over to our engineering teams that have been building the Snowflake emulator and actually will also be at the Snowflake Summit. So if you have time, you can meet your heroes in person and say hi.
Thanks, Gerda. Thanks, Valdemar. That was great. So yeah, as you can tell, we're super excited about this product. We want to share more of that. So we've got our engineering team here to talk about what's actually new in 1.0. So Shemek is going to come up and tell us all the new features that were just released last week. Shemek, take it away.
Thanks, Brian. So I just want to also give shout out to the whole LocalStack team, and especially to Snowflake team, to Erudit, Sabir, and Gentries for the tremendous amount of work we've put into making this happen. And special shout outs also to Valdemar for support along the way. We really appreciate that. So yeah, I would like to dive deeper into what's new in LocalStack for Snowflake in V1 release. So yeah, let's kick things off. So we added support for native apps, and Snowflake Emulator now supports it, enabling you to build, test, and validate native applications locally. So basically, you can create your application package, then create application from that application package, and even you can embed a Streamlit application inside a Snowflake native app. And Streamlit is Snowflake framework for building apps. And if you want to give it a try, you can go to native apps example repository, which Snowflake published, and you can choose one of the examples and just give it a try with the emulator. It will also demo one of the native app later on, and this demo will be presented by Erudit. Yeah. The next feature we added is Polaris catalog integration support. So Polaris catalog is an open source catalog implementation for Apache Iceberg. It follows the Iceberg REST catalog specification, and it enables multi-engine interoperability. Polaris supports different query engines and database platforms like Snowflake Dremio, also Trino, which I also gonna present later on. And in order to use catalog integration with Snowflake Emulator, we need to run create catalog integration query, which is presented on the left-hand side, but I will dive into more details during my Polaris catalog integration demo later on. Next feature is materialized views, and LocalStack Snowflake now supports materialized views, allowing developers to create pre-computed persistent views. Standard materialized views support in the database space, and we support the following operations like create, alter, describe, drop, show, and truncate. Next feature is row access policies, and it allows developers to implement test fine-grained role access controls locally. So basically, you can create a table first with this query on the left-hand side, then create a row access policy that is basically masking a column username here, and then enable the row access policy on the table using alter table query here, and we're just basically adding the row access policy to a table and enabling it on the username column. Recently, we added also multi-account support. So as you are aware, Snowflake supports like multi-account configurations, allowing to like having like multiple accounts in the same instance. And we do support it right now, and we do this by like provisioning separate Postgres SQL backends for each account to ensure that we have like complete separation and isolation of data and namespace. And this is like very useful for testing multi-tenant applications or workflows across like different environments, different stages and accounts. Next feature is transaction management. So previously we supported only auto commit mode. So all operations were like automatically committed to underlying database. And right now we are enabling developers to have like more explicit control over your transactions using standard SQL commands like begin to begin the transaction, then commit to commit the transaction, rollback to rollback the transaction, also select current transaction function to show the current transactions, and show transaction to show all open transactions being open. Another feature is passwordless authentication. So Snowflake emulator supports right now passwordless authentication, and it's basically you need to generate an iris key keys, and then attach the public key to your username, and then use the private key in your Snowflake connector configuration. For example, like in here we are using Snowflake Python connector, and we are pointing to iris key, private key via the private key file property here. So it's very useful, and I think right now Snowflake enforced MFA for every account. So yeah, that might be your default authentication option right now. So we also emulate that functionality. Another feature is Java UDFs. So we added support for Java UDFs. We had support for Python UDFs and JavaScript UDFs, and we added also support for Java UDFs. So what we can do now is we can create a function and then point to a Java language, choose a version of Java, and then point to a stage in Snowflake where your built-in compile jar is located. And then the endpoint to the handler, which is the function, the method in the Java. And after it's created, you can basically use this concat string function in the emulator. So that's a pretty cool feature. So yeah, we are kicking off take demos. That's a pretty exciting part. So I'm gonna present Polaris catalog integration, and then Erudit will present 2 more demos afterwards. So before I start, you can find my demo by you can use this link or use the QR code to follow along, and maybe like try it out, and maybe also like share some more feedback on how it works, and just give it a try. So before I start, I would like to present like a diagram what's going on in this demo. So we have 4 different components. One is LocalStack Snowflake emulator. Second one is Polaris catalog. Then we have LocalStack S3 object storage bucket. which would contain Apache Iceberg tables with all metadata files and Parquet data files. And also Trino, which is distributed query engine as an external query engine, just to show the interoperability in Polaris catalog. So everything will be spin up using the Docker Compose locally in 3 different images. So Polaris catalog is as a one image, LocalStack, Snowflake emulator, and LocalStack S3 as the second image, and Trino as third image. And LocalStack Snowflake emulator would talk to Polaris catalog via catalog API. Same for Trino, and LocalStack and Trino will talk to LocalStack S3 local object storage bucket to read and write data. And Polaris catalog will exchange the metadata, and we handle the metadata management between bucket and the catalog. So yeah, I think that's all slides. So let's kick off the demo. So first of all, I can quickly show Docker Compose here. So as I said, this is LocalStack Snowflake that contains Snowflake emulator and also S3. Second image is a Polaris catalog image, which is maybe I will just make it a bit bigger. All right, so Polaris is the second image with some extra configuration, which points to endpoint, which points to LocalStack endpoint, and is using like some LocalStack specific configuration to AWS. We are also running like a short bar script to set up a catalog within Polaris catalog that will be used by LocalStack Snowflake. And the last image is Trino, which has Iceberg connector configured that points to Polaris catalog and also to LocalStack S3 bucket. So yes, let's run it. Docker Compose up. It'll take a while to initialize. I'll move it here a bit. Okay, so this is still starting. So yeah, first thing we need to do, we need to create a bucket here. So I'm going to use AWS local CLI wrapper around AWS CLI to create this bucket. And let's wait a second. So bucket is created, and we can proceed with a demo. So on the left-hand side, I have a dbeaver running, which is connected to LocalStack Snowflake emulator. And first of all, I need to create an external volume, which points to bucket that I've created, test bucket, and just like some extra configuration to the external volume. So yeah, creating external volume, it's succeeded, so we can proceed further. The next step is to create a catalog integration. So here we are we're calling our catalog integration Iceberg catalog. Then a catalog source Iceberg res, table format Iceberg. We're calling catalog namespace test namespace, and we are pointing to locally running Polaris catalog. And some extra authentication credentials to Polaris catalog. So let's create catalog integration. It's successfully created. So now we can create an Iceberg table. And here we are calling our Iceberg table. We're pointing to a catalog integration Iceberg catalog. and to external volume, iceberg volume. And we are setting some base locations. So let's create an iceberg table here. The table is created. So then we can insert some data into it. We can see like a lot of movement in the logs on the right-hand side, by the way. So yeah, data is being inserted. Yeah, it's there. So let's select data to see if it's there. Yes, I can see the data is there. So let's see right now what is in the bucket. After we created the bucket, then we like created the table, populated the table, and we can see that there's anything else there. So let's do list objects from test bucket. And here we see some Parquet files, Parquet data files associated with iceberg tables, and metadata JSON file, which is iceberg metadata files. So we are seeing that Snowflake emulator actually wrote the tables, the metadata and the data files here. So let's right now, as a last step, test the interoperability, whether we can actually query this data from a different engine. So what I will do is run Trino CLI. So I'm using Trino right now. And I'm switching context to use Iceberg catalog and test namespace schema. And I can just run a select from Iceberg table. And yeah, we see the data and we can successfully query Iceberg table that was created from LocalStack Snowflake from Trino. So we presented the interoperability of the whole setup and demo. And yeah, that's it. Looking forward to hear your questions later on. And yeah, I will right now move to the second demo. Thanks.
Thanks, Jeremy. That was great. We just a reminder, if you have questions, and I know some people have already gotten their questions in, we will be doing Q&A at the end. You can find the Slido link if you want to post it there, or you can use the chat on LinkedIn or YouTube, however you're joining, and ask your questions there as well. But we've got one more demo before we hop to that Q&A. So, Eridit, welcome to the stage. Take it away.
Thank you, Brian, and thanks, Przemek, for the Polaris catalog demo. That was super exciting. Okay, for the next one, up here on my browser, I have the Snowflake localstack.cloud documentation, where as a pointer to all of you, we have all our guides and our documentation for every service that we support. So right now we're going ahead to show an example on how to use snowpipes. So snowpipes in Snowflake actually enables you to load data immediately as they're available or uploaded on a stage. That means it has its advantages over, for example, just manually or explicitly using copy statements to load data via a scheduler or something explicitly. For that, we are also using some of the AWS services such as S3 bucket to kind of store data in a stage format, and SQS, for example, to emulate the way that the process of loading data happens in Snowpipe. So let's get started with a simple example and see we can see how to create a snowpipe and how the data actually is being loaded into a target practically. So first and foremost, I'm going to make sure that I'm going to start my LocalStack emulator, and for that you need LocalStack Snowflake Docker container. We are using LocalStack CLI here, and we are just making the terminal print more logs with debug equal to 1. With my emulator running, we can check if everything is working properly by bringing up a SQL client and just running a simple query here. We can show that everything is connected, so that's all right. And what we need now for the Snowpipe example, first and foremost, we might need to store it. So we're going to create an S3 bucket with AWS local, which was mentioned before as well. And then we are going ahead and create a stage. Now to create a stage, this is the exact query. We can create a stage pointing it to the S3 bucket I just created with these credentials, which are mocked out because we are using the emulated version of S3 and SQS, which also come as bundled emulation services with the Snowflake emulator as well. Instead of using an explicit like type JSON file format, we can also create a named file format, but we're going ahead and just create it like it's being stated in the docs here. So we created a stage. We will create a table, which will be the target of my data next up. And if I select now everything from this table, then we shall see no records for now, and that's expected. And now I'm going to actually create a pipe. The way pipes are created is you define a copy into statement, which identifies the source location of the data file and the target table where the data shall be loaded to. Now, I don't really need this file format. Let's keep it simple. And we are going to create this pipe. Now, if I run show pipes here, we can see the pipe is created, and we can also see its definition, so the copy into statement and its notification channel, which is basically the topic that it's subscribed to listen to for new messages coming in our case, the data. And now we are going to use AWS local again to actually put some data into the S3 bucket. In order to do that, first and foremost, we are going to use the API, the put bucket notification API, in order to actually trigger a notification whenever an object is created in the S3 bucket. So I'm going to create a notification.json file here with this configuration. And with this being done, I will actually configure the notification in the put bucket notification configuration in the bucket itself. And then what I need to do is to actually just create a file, in our case, a JSON file, because we set up our stage in that format. For that, I will create a new test JSON that will just have simple JSON files, JSON records to be correct. And then I will copy that JSON file in our S3 bucket. So we're going to upload the file to the S3. And with the way we defined or we created the pipe, data should already be available in the target table. So if I run select from table again, we are going to see the data, the two records that are uploaded to my test table. On top of that, we can also directly, of course, query the same data from the stage, or even select metadata from those things like file name, for example, or metadata file row number from this test. From the stage, which will actually just show or just query the metadata from the records that we loaded in this stage. So yeah, this is as part of me showing how Snowpipe works. And with that out of the way, we shall continue with the next example, which is the news about native apps and how we emulated those. So again, we do have documentation and guides on native apps, so native apps in Snowflake are actually just a framework that helps you create and deploy applications with core SQL functionality integrated. Snowflake itself has a repository here with their own examples, one of which we are going to show is this task streams. They have their own README file. Of course, you will expect the structure. We have a manifest file defining artifacts with a setup script with the integration with or the actual default path to the Streamlit UI, which will visualize the application, etc. So to show that, I'm going just to restart my container here in order to have a fresh environment. And then I'm going to go here. This is me I went ahead and previously cloned the repository. So I'm going to go in the task stream folder. Again, we are going to show there is a setup script which will set up everything, objects, roles, procedures that the application is going to need. And what the application is actually going to be is just a demonstration on how to start, stop, and refresh to see a task being scheduled and being run. And this task is being created and is scheduled to be run 1 minute. Because of time, I'm going to make it 10 seconds for the purpose of simplicity. And a little disclaimer here that I'd like to mention is that in this initial implementation of native apps, we don't currently support references 100%, so it might be good to comment this line out in order to make things simpler. And all we need to do really is just to deploy this app, which actually will build a native app and will run a Streamlit server. And that is done with Snow CLI. We can just run Snow app run, and it should be good to go. Another disclaimer here, you need to have Snowflake CLI installed and configured with LocalStack connection configuration. You can also find integration guides here on how to do that with Snow CLI. I myself have configured the connection to LocalStack being the default one, so I use that, but yeah. And yeah, with that out of the way, we can move ahead. This actually is the URL in which the app is deployed. It's part of the output script of the Snowflake repository. The actual one, or the correct URL is this one from the docs that you can find here. I'm going to go there, just replace the username with my username. And if luck is on my side, the application should be loaded. Here we can see the dashboard with the value, which will be incremented every 10 seconds whenever we start a task. So we can see when I clicked start task, a task started. Now we just need to wait 10 seconds for this to be incremented. I can also show here the logs of everything. I can refresh and see that value is incremented. So we can see 1 here. And then, yeah, then there's 2. You get the gist. And then running stop task should really just suspend the task. So if we wait a little bit more, then this number shouldn't increment anymore. And yeah, this is what we're seeing here. And seems like everything is working. So I guess, yeah, that's it in regards to native apps too. So yeah.
Thanks, Harry. That was really great. So it looks like when I see the comments going throughout this presentation, it's been nice to see everybody just so excited about everything. I saw people saying amazing, good stuff, and applause. So I'm it's really cool to see how far this product has come, and how excited people are to see it. So, with that, I want to kind of jump into. We did have a bunch of questions on Q&A. Yeah, that we're showing some of the comments here. Thanks, Meridian. We got obsessed by AWS saying great demo. We also had like Duncan giving us applause. So like really appreciate you guys sharing your comments in the chat. But I do want to get to questions. So we had some questions. First of all, will you be able to test things like failover groups with replication for DR testing, or where can I see what is currently supported and what not? Who wants to take that one?
Yeah, maybe I can briefly, Premi, also feel free to chime in, but we have on our website, on our docs that Ariel also showed, snowflake.localstack.cloud, we have a feature coverage page where we kind of have a pretty detailed overview of what's currently supported in terms of types of queries and also SQL functions. So for this particular one, I think we'd have to look into the details. So I'd say it's currently not yet implemented, but certainly part of our roadmap. So as part of the next couple of weeks, we also want to make a bit of more publicly facing roadmap accessible to you all. So to kind of make this a bit clearer what's going to be supported in the upcoming releases. But yeah, coming soon, but right now not supported yet.
Awesome. Okay, good to know. Next question is, let's see, any plans to support Gen AI workflows with Cortex in the emulator? So I guess another roadmap question here.
Yes. So I can take this one. So yeah, we have it on the roadmap to look into like Cortex AI capabilities to emulate them locally. So yeah, that's definitely coming. We are not sure when exactly, but expect some more updates soon.
Excellent. Okay. So next question is, let's see, are Snowflake and AWS services packaged together? Any way we can opt for only Snowflake?
Yes, we're finalizing certain details there on pricing and packaging, both together and separately. So the answer is yes, you will have flexibility. You will be able to get Snowflake separately, and you will be able to also package it together with AWS.
Do you think there's also like I think to maybe on a technical side, there are some services that we are dependent. So like there are certain AWS services that kind of come packaged with the Snowflake emulator by itself. Am I right about that? Maybe you all can explain a little bit more in detail.
Yeah, maybe I can just complete on this. So like we showed on the Snowpipe example, for example, under the hood, it uses a queue messaging system to subscribe and listen whenever actual data are being loaded in storage somewhere. So there are certain features that are depending on some AWS services. And yeah.
Yeah. So from a product standpoint, like from a purchasing standpoint, you can be able to buy it separately, but also like there are going to be some underlying emulator pieces that are packaged in from the AWS emulator. So is kind of the short answer, I guess, right? Excellent. Okay. Are grants, metadata tables, and functions like system verify catalog integration simulated? And I guess organization usage.
Yeah, like we do support some of the metadata tables. Maybe feature parity is not yet complete there with metadata tables. Same for grams. I think like we have like some support, but you would need to give it a try, whether like everything works correctly. And this particular function, I guess it's not supported as far as I know. Yep.
Okay, great. But maybe added on the roadmap somewhere. Who knows? There's a lot of. I mean, we are a 1.0 product. I mean, it's not. This is not like we have a long way to go. I mean, if you think even about like how many years it's been getting ourselves up to the parity level we're at on AWS. So I think we're in a good spot though where we are right now. Can I connect to S3 Cloud when using LocalStack for Snowflake?
Yes, it's possible right now. It requires some extra configuration via the environment variable. I don't remember now which one it is, but you can find it in our documentation under configuration, this environment variable, and just point to like S3, real S3 endpoint.
Excellent. Okay. All right, and this is a comment, more of like a comment and a question, but we'll kind of take it anyway. Which is Thanos asks, please create a free tier plan for this, like you have for LocalStack AWS. I'm sure you're not surprised this comment question comes up. I don't know who wants to kind of address that.
Yeah, this is a great point. I mean, generally speaking, in this first version, if you go to our website, you'll probably see that it's currently talk to sales. So we have it's not self-servable yet, but it will be in the upcoming weeks. We're also gonna introduce a generous free trial for 30 days for this product. We want to make sure that everybody gets a chance to try it out, make sure that it satisfies your use case. And then also we have some program for non-commercial use. For example, if you happen to be using this for some open source projects or for something else that's not commercially, then please reach out to us and we can find a solution. Definitely always want to try and make sure that it's broadly accessible, and we were optimizing for broad adoption for this product, especially as it's sort of in the early stages now. So please do reach out and look forward to getting your feedback there.
Thanks. Appreciate that. Okay. Well, with that, that was our last question. I think I'm turning it over to Harsh. You had, yes, community and resources. Yeah.
Sounds great. I guess I'll just do like a basic round on all the community and resources and what would be coming next with regard to LocalStack or Snowflake. This is going to be quick because we are already running out of the time. So as Erudit and Shimek have already been sharing with you, we have been working really hard on building the documentation for our Snowflake product. So if you have never interacted with this before, you can definitely go and hit snowflake.localstack.cloud. And this is our central documentation where you can find all of the Snowflake features that we are providing right now. Down in a few weeks or maybe a few months, we will be entirely migrating to a new documentation framework where you will be finding both the AWS documentation and the Snowflake documentation at the same place. But we will be ensuring that you don't find any dead links whatsoever. So for now, feel free to hit the documentation and get to see all the different features and all the different capabilities that the product provides and try to make the best use of that. Apart from this, we also have like a bunch of sample applications that our team has been building. Just like Shemek has been showcasing his Polaris catalog sample application, we have like a few more on this particular repository. The link for that you can basically find right on the chat section. But you will find like a bunch of sample application that concern like different use cases. So for example, we have a sample application surrounding machine learning and data engineering, another sample application surrounding data quality checks with Soda. Then we have another one that basically allows you to see like how you can do dbt transformations on Airflow. And Airflow is like also one of the managed services that we emulate via our AWS emulator. So you can technically find like a bunch of different things that will allow you to understand the different ways in which you can run and test your Snowflake workloads pretty much on your local machine. Now, the big question is, how do you get started? And this is something that a lot of people had confusion with in the past. So previously, the Snowflake emulator was right in our public preview. So it was accessible to everyone who had a valid auth token. But going forward, we are investing like much more efforts and resources on fleshing this out. So if you're looking to get access to this, we are getting this behind a particular form, which is very easy for you to fill out, and you can technically request for access, and we can have a good conversation about what are the use cases that you find the Snowflake emulator to be useful for. Apart from this, if you have got any questions or help, you can always reach out to us via our web application chat, or you can directly email us at this particular email address. And finally, all your feedback is valuable. And we definitely want to get more feedback around the new features, around the new stuff that we can emulate and support. So you can always reach out to us via our Slack workspace. And we have like a huge community out there, not just from the Snowflake ecosystem, but also from the AWS ecosystem, and maybe a spoiler alert, but also the Azure ecosystem that will be coming out very soon. So it's a great place for all of you to geek out and interact with us and basically influence the direction in which we are taking in regard to the product that we are building. Uh, just covering up like a basic brief of what will be coming next, given the fact like we have such a strong team, you can expect like many more releases to come as we further look forward to enhancing the parity and making the whole product more stable. But this is just a bird's eye view of all the different things that we would be working upon. So we will have like a much better support for stuff like role-based access control, cloning support, third-party integrations, information schema, JavaScript procedures, and more. We're also building support for Snowflake REST API endpoints, tabular SQL UTTFs, time travel and failsafe. And as Waldemar already talked about before, we are trying to enhance our cloud pods and persistent support even further, because we think like it is going to unlock a lot more capabilities, such as around test data management and things of that sort. And we are very much excited to explore these opportunities with you. And finally, our bread and butter is enhancing the parity. So we will try to build more parity with the Snowflake SQL so that you don't feel like something that, hey, I just wrote this SQL query on the real Snowflake and that works, but it does not work on LocalStack. We don't want to get into those kind of scenarios or gotchas. So just be sure that we have got your back on this perspective. And finally, as Gerda mentioned before, we are going to be at Snowflake Summit. So if you are attending the summit and if you're going to be there, then feel free to hit our booth, 1105. And we'll have like a bunch of team members over there. Me and Brian are surely going to be there. Waldemar and Gerda are also joining us. And we'll have like a few more people from our technical GTM and solution architecture team. So that's a great place for you, including Shemek, as always, our lead engineer on this product. So it's a great place for you to come and talk to us, interact with us, and get to see the direction in which we are taking to build out this whole product. Also, it would be a great place for you to see some exciting demos that we have been working really hard on. Personally, I have been working very hard on that. But jokes aside, I guess this is very much it. We have gone through the Q&A, so I don't think like we have more questions coming out on this. So that brings
Nope.
us to the end of it.
Yeah, thanks, Harsh. As everybody can see, there's a lot of information already out there. I hope that you check it out. And again, we look forward to your feedback, however you want to do that, whether it's on Slack or via email or one of our any of our community channels. So please reach out if you give it a try, or if you just want to give it a try. We'd love to hear from you, hear what your use case is. There's a lot more to come, and I mean, I can't believe Snowflake Summit is literally next week. So yeah, we will be there. It's gonna be fun. Poor Harsh has to travel like halfway around the world to make it there. He's gonna do his round the full globe this trip. So yeah. So yeah, we'll be excited to see you there. So if you're going to be there, come check us out. And thanks for joining us today, and hope we'll see you next month. Okay.